In this video, I'll solve two questions on continuity of function. The first question says, find the value of c and k which make the function f defined by f of x equal to x if x less than or equal to 1, cx plus k if 1 is less than x and x is less than 4, minus 2x if 4 is less than or equal to x, continuous on the set of real numbers. To determine the value of c and k, we need to ensure the continuity of the function at the boundary points, that is 1 and 4. These are the boundary points, okay? So we need to ensure that the function is continuous at x equal to 1 and at x equal to 4. For the function to be continuous at x equal to 1, the limit as x approaches 1 from the left must be equal to the limit as x approaches 1 from the right. This is what I'm saying. The limit of the function f of x as x approaches 1 from the left must be equal to the limit of the function as x approaches 1 from the right. Now, what is the limit of the function as x approaches 1 from the left? As x approaches 1 from the left, we are talking about numbers less than 1. I can see here x less than 1. That means I will use this function to determine the limit as x approaches 1 from the left. So that means I will use this. In place of x now, I'm writing 1. So this is the limit as x approaches 1 from the left. Okay, what is the limit of the function as x approaches 1 from the right? So as x approaches 1 from the right, we are talking about numbers greater than 1, okay? I can see 1 less than x, and that means that x is greater than 1. So this is where x is greater than 1. That means I'll use this function to determine the limit as x approaches 1 from the right. So the limit as x approaches 1 from the right will be, in place of x here, I'm writing 1. That will be c times 1, which is c plus what? K. Now, for the function to be continuous at x equal to 1, both left and right hand limits must be equal. That's what we stated here earlier. So, in this case, I can see that 1 is equal to what? C plus K. Equation 1. Now, let us consider the second boundary point, x equal to 4. For the function to be continuous at x equal to 4, the limit of the function as x approaches 4 from the left must be equal to the limit of the function as x approaches 4 from the right. As x approaches 4 from the left, we have x less than 4. I can see it here. X less than 4. So I will use this function to determine the limit as x approaches 4 from the left. In place of x, I'm writing 4. So it will now be 4c plus k. So here I have 4c plus k, which is equal to, let's determine the limit as x approaches 4 from the right. X approaching 4 from the right implies that x is greater than 4. So where can I see x greater than 4 here? This interval says 4 less than or equal to x, which means that x is greater than or equal to 4. So here I can find x greater than 4. That means I will use this function to determine the limit as x approaches 4 from the right. In place of x, I'm writing 4. So we have minus 2 times 4, which is minus 8. So at this point, I will have minus 8. I hope you get it. This is equation 2. Okay, Let me write it to resemble this equation 1. I can say minus 8 is equal to 4c plus k. We have two equations. Let's solve them simultaneously. Let's solve. I can easily eliminate k by subtracting either equation 1 from 2 or equation 2 from 1. So if I say equation 2 minus equation 1, that will be minus 8 minus 1, which is this 1, is equal to 4c minus c plus k minus k. K minus k is 0. Minus 8 minus 1 is minus 9, which is equal to 4c minus c is 3c. If I divide both sides by 3, 3 cancel 3, c will be equal to minus 3. Alright? Minus 9 divided by 3 is minus 3. To get the value of k now, let's plug in minus 3 for c in equation 1. So here I'll write minus 3. We have 1 is equal to minus 3 plus k. Collecting like terms, minus 3 will cross and turn to a plus. So k is equal to 4. So the values of c and k which make the function continuous on the set of real numbers are c equal to minus 3, k equal to 4. Question 2 says, find the value of k which makes the function f defined by f of x equal to 3x plus 7 if x is less than or equal to 4, kx minus 1 if x is greater than 4. Continuous on the set of real numbers. To determine the value of k, we have to ensure that the function is continuous at the boundary point. The boundary points are 4 and 4. Of course, 4 and 4, they are the same. For the function to be continuous at x equal to 4, the limit of the function as x approaches 4 from the left must be equal to the limit of the function as x approaches 4 from the right. The limit of f of x as x approaches 4 from the left must be equal to the limit of the same function as x approaches 4 from the right. As x approaches 4 from the left implies that x is less than 4. Okay, so where do I have x less than 4 here? I can see that x is less than 4 here. So I will use this function now, this subfunction, to determine the limit of the entire function as x approaches 4 from the left. In place of x, I'll write 4. So we have 3 bracket 4 plus 7. Okay, let's go ahead. Just keep watching. As x approaches 4 from the right, implies that x is greater than 4. This is where x is greater than 4. So I'm using this subfunction. In place of x, I'll write 4. So we have k times 4 minus 1. So you can see that an equation has been formed based on that principle. 3 times 4 is 12 plus 7. K times 4 is 4k minus 1. So let's solve. 12 plus 7 is 19. Collecting like terms, the minus 1 will cross and turn to a plus 1. We have 19 plus 1 equal to 4k. So 20 is equal to 4k. Dividing both sides by 4, it is obvious that k is equal to what? 5. So the value of k, which makes the function continuous on the set of real numbers, is 5. Keep watching. I'll see you in the next one.